On to stoichiometry with gases. So stoichiometry, like any other time we've talked about it before, is when you have a chemical reaction, you have to take into account that there's a mole ratio in the balanced chemical equation. So the steps are going to be exactly the same. We're just going to add some gas laws in there. So step one is to have a balanced equation. So anytime you have a chemical reaction, you need to follow the stoichiometry steps, which is to convert to moles, mole ratio, and convert to whatever it is you're trying to find. The same steps apply here, even if you're using gases. You're going to convert to moles. Now, instead of having grams to go to moles, like when you use the mole or mass, I could give you liters of a gas. So if you have liters of a gas, you're either going to have to use Pivnert, or if we're at STP, we know that 1 mole of any gas is 22.4 liters. So you can use that conversion. So we actually don't need the molar mass here at all, unless I actually give you grams or I want grams. If I don't give you grams, you're going to have to use Pivnert, or this 1 mole is 22.4 liters conversion. Okay, that's the difference when you're using gases. And you still have to have your mole ratio, which is your wanted thing over your given thing. You pull those coefficients from your balanced equation. And finally, convert to what you want. If I want grams, you just use the molar mass. If I want liters, if I'm at STP, you can again use the 22.4. Or if it's Pivnert, you can, or if it's not at STP, sorry, you can use Pivnert. Okay, so this is just like an example broken down into the steps. If I gave you grams, you would convert to moles. So again, converting to moles works the same way as always. If I have grams, I use the molar mass like I did here. If I had given you liters, you could have used 22.4 or Pivnert. And then you get your mole ratio from your balanced equation to get you to moles of the other thing or whatever it is you're trying to find. And then you can do it like this times RT over P, or I like to just calculate the moles number and then plug it into Pivnert to get to liters of chlorine, if that's what I was trying to find. Okay, so you have to keep in mind that there is kind of another island. If you like the mole island analogy, there's a volume island that you can convert to and from liters using 22.4 is 1 mole if you're STP, or using Pivnert if you are not. Okay, so example number 11, I think I'm going to do that one with you. All right, so first of all, how do I know this is a stoichiometry problem? Well, I have a balanced chemical reaction. Anytime you're doing a chemical reaction and I'm wanting to know how much stuff you're going to make or how much stuff to use, you have to do stoichiometry, convert to moles, mole ratio, convert to whatever it is that you need. Okay, so then I'm going to like pull out my numbers. Let's see what I have here. I want a volume. So I want liters most likely. I'm looking for volume, okay, of oxygen. So I want this one. This is my wanted. Okay, of oxygen is collected at, I have a temperature of 23 degrees Celsius, which I know I'm going to have to put into Kelvin. So I'm just going to do that right off the bat. So that's 296.15 Kelvin. And 0.994 atmospheres, well, that one's a pressure. When 4.50 grams of KClO3 decomposes. Okay, so this is what I'm starting with. Okay, I know this is stoichiometry just because I'm giving you one thing and I'm trying to get to another thing. I'm giving you KClO3 and I'm trying to find oxygen. So that being said, that's another way to figure it out if I didn't actually give you the equation. If you're going from one type of compound or atom to another, it's definitely stoichiometry. So we're going to do the convert to moles, mole ratio, convert to whatever you want. But what do I start with, right? I've got a temperature, I have a pressure, and I have a grams. How did I know that this is what I'm starting with? Well, here's my little tip over here. If you're not sure what number to start with when you're doing your stoichiometry, you want to always start with an amount. So it's either going to be grams or liters. Now, you're only going to have one of these. If you have two, you're probably going to have to do 2 stoichiometry problems. So I do have a grams over here. So I know I'm starting with 4.50 grams of KClO3 over 1. Now, this is grams. So my first step is to convert to moles. Well, this isn't a gas yet, so all I have to do is use molar mass. So I find the molar mass of KClO3 is 122.55 grams per mole. So that'll get me to moles of KClO3. So that unit works. So I convert it to moles. Then I need my mole ratio. Ratio is always wanted over given, or if you're just trying to check your units, that's fine. KClO3 should be on the bottom. So you look at your balanced equation, that's a 2. So it would be 2 moles of KClO3 to, what am I trying to find? I want O2. I already marked that earlier, so that's going to be 3 moles of O2. Now, if I stopped here, because these cancel out, this would tell me how many moles of O2 I make. What do I want? Well, I want volume. Okay, the easy way, it would be if we were at STP, so temperature of 273.15 and 1 atmosphere, I could just multiply this by 22.4 and get my answer. Unfortunately, I am not. So what I like to do is I like to stop here, calculate how many moles that is. All right, so you do that math, you get 0.05508 moles of O2. Okay, I want volume. I have a T, I have a P, and now I have an N value. Well, the only equation I can really use that has all of those is PIVNERT. So I'm going to use PV equals nRT, plug everything in, and I can solve for that volume. So I've got 0.994 atmospheres times V equals 0.05508 moles. Because this can be for any substance. It doesn't have to be oxygen. R 0.08206 and T 296.15 Kelvin. Solve for V, I would get that the volume is 1.35 liters. Okay, so this is for gases. All right, now we've done stoichiometry with grams to grams. So that was like our first type. We've done stoichiometry with solutions as well. So when we have solutions and molarity, you use your molarity to convert to moles. When you have a gas, so if I'm giving you like pressures and temperatures and things, we use PIVNERT to get to moles and whatever else we are looking for. Okay, so we're just kind of throwing another possibility in there. The steps are still the same. So I would like you to try example number 12. It says what total volume of gases would be produced at 21 degrees Celsius in 1 atmosphere when 5 pounds of TNT explodes. Now, yeah, I gave you pounds, so you should convert that to grams first. I think that conversion is on this sheet. If not, 1 pound is 454 grams. That's a good one to know. Now, if you're looking at this equation, you should be able to tell that the big compound is going to be TNT. It's going to explode and you get nitrogen, water, and carbon monoxide gases, and then some regular carbon left over. So if I want to know all of the gases, I want to know all of the nitrogen, water, and carbon monoxide that's going to be made in liters, right? Volume of gases. Now you could do all three separately, like do a mole ratio for each one and then add them all together. But the easiest way to do this is because it doesn't actually matter what the gas is. You can plug it into PIVNERT and use moles no matter what. Just add up those coefficients. I would make 3 moles of this, 5 moles of this, and 7 moles of this. So that's 15 moles of gas total. So for your mole ratio, you would do 2 on the bottom for TNT, makes 15 moles of gas on top for your ratio. So go ahead and give that a try and then check your answer. Okay, I did my conversion, converted to moles with the molar mass of TNT, 15:2 ratio. I would make this many moles of gas, which is a lot of gas. Okay, for what was this, 5 pounds of TNT. Plug that into PIVNERT, just like I did in the last question, and make 2,980 liters. Now, if you think about it, that should kind of make sense. 5 pounds of TNT creates a lot of gas. So 2,980 liters would be an appropriate answer if I wanted to make sure my answer makes sense. Example number 13 says calculate the volume of NH3 gas produced. So I want volume, that's liters, of NH3 or ammonia gas produced in the reaction. Okay, gas is like my keyword here, right? I'm going to have to use PIVNERT or 22.4 in the reaction of 4.23 liters of hydrogen with excess N2 gas. Now, some of you guys get tripped up when it says excess something. That just means the amount of N2 doesn't matter. I'm not going to run out of it. So this is my limiting reactant. Assume the volumes are measured at the same temperature and pressure, or I could have said at standard temperature and pressure. You can use whatever you want to. Now, I only gave you one number, so I would start with that number, okay? 4.23 liters of H2. Now, this whole STP thing means that instead of using PIVNERT, I can use that 22.4 number. So if you want to go ahead and try to set it up, you can, but I am going to walk through it. Okay, so I would start with my 4.23 liters of H2, and you'll notice I only did the mole ratio here. I want ammonia, and I have hydrogen on the bottom. Why did I do that? If you look at the equation that I wrote here, oh yeah, I need to go back to that, right? I didn't give you a chemical equation. How are you supposed to know this was a stoichiometry problem? Well, I'm looking for NH3. I'm reacting H2. Those two are different things with this. So you would need to write a balanced chemical equation first, okay? So this is a 2 to 3 ratio of what I'm trying to find. And instead of converting to moles, doing my mole ratio and then converting back, if I'm at STP, both of those conversions are going to be with 22.4. They're just going to cancel out. Also, if you remember back when we were talking about those balanced equations, this is a 3 moles to 1 mole to 2 mole ratio, but it's also for liters. This is a 3 liters of this reacts with 1 liter of this to make 2 liters of this ratio. So if you're at the same temperature and pressure or at standard temperature and pressure, you can just use a mole ratio and that's completely fine.